if there are any questions, just let me know. We can certainly go over that before we get started. So I want to make sure before we get into the weekend, you guys are not blocked or anything, and can finish it by Tuesday. So it'll be really good to review it. All right, so today we will continue with our data structures class, and we will do a bunch of exercises in class. So did you guys do any coding exercises on the mock interview, in the mock interview process?
Yeah, I had one.
Yeah. What type of a coding exercise was it? What did you have to do?
Reverse an array.
Okay.
Yeah.
And how did you do that?
It was okay. I got stuck for a moment, but then the interviewer helped me.
Okay. How did you reverse with? Can you explain how you did that at the end? Like, well, just the logic, not the describing the code, but the logic. Are you able to explain?
Yeah, well, I guess I didn't get the requirements correctly. I just printed them out backwards. But in fact, he was asking to keep the same array, but then change the elements in the array.
Mm-hmm.
Yeah, but I used a temporary holder.
Okay. So basically, going through the array, probably from the end, right?
Yeah.
Gotcha. Right. And putting that in a temp array. Okay. And then returning that. Interesting. That's actually one of the exercises I had on my agenda. So let's talk about that. I think that's a good start to our session. I'm looking for feedback from the team. So let's take that as an example. What Donna said, exercise to reverse an array, but one of the requirements is to do that in place. So in place means you cannot, use a new memory footprint, right? Remember we talked about kind of memory footprint, and so not creating a separate data structure. So how would we do that? So you're passed an array and you have to do reversals within that same array. How would you do something like that?
To reassign, not in order not to create a new array, we can reassign just through. We should go. We should use for loop and go through each index inside array and reassign first 0 index to the last one and go one by one, traverse it.
Okay.
Yeah, and we can split when we write the logic of for loop. We can do it not so we can start with the index 0, and we can continue not till the last index. We can continue till we should divide our array's length by 2. Yeah, and it will save our time.
So you probably are familiar with the binary type of.
Yeah, I think it's a binary how it called binary
sort of binary
approach. Yes.
Yeah.
Yeah, we have do it a couple of times with the scar. If I'm yeah.
Cool. Yeah. Binary.
And also, yeah, here we should create temporary variable in order to store something that we will reassign, as Dana said.
So let's go through that. So one thing I want to emphasize, I want to go through this exercise is because when you go into interviews like that, right, it's very, very easy to just jump into coding, right, and start writing the for loop and all of that stuff. And if you have a little bit of pressure, somebody's watching, you may get a little, lost in your code, right? So what I usually recommend is just writing out the logic. Just kind of think about something. There's one thing that's called brute force approach. So what that means is basically if you were doing this without the computer, right? So you don't have Java, you don't have anything, and you have an array, right? So let's get an array, So you get this array, right? I think that's enough. So each, it's divided by spaces. So you have, some double-digit elements in there. So now the problem is you need to reverse it. So instead of this array, you get the reverse, which would start with 5, 7, 6, 1. So the same, and you cannot use a different array. So you can't just go and put this into separate array and then return that. So let's start. So certainly looking for everybody to jump in. So how would you approach this if you didn't have computer, right? So what would you do? What do you have to do?
What do you mean? Go ahead, then.
Oh, well, if I didn't have a computer, I would just take an element from left and right and then switch places.
Cool. Yeah, makes sense, right? So you basically, if you were to do this on paper, right, that's kind of what I mean by without computer, you take 2, swap it with 5. You take 5, swap it with 7. 6, swap it with 1. 8, swap it with 1. And 34, swap it with 55, right? So you have kind of the first thing, right? You need to swap, right? So then you're going to be swapping from, like you said, left, swap leftmost with rightmost. Okay, cool. All right, so we're swapping. When do we stop? How do we know where to stop, right? So we get to 34 here, it's easy because we kind of see it, but how would you go and swap 55 with, how would you know when to stop?
We split it into 2 parts. So left and right of the array, and then we stop at the middle.
Sure. Okay. So like you mentioned, so basically split the array in 2 parts.
Mm-hmm.
Okay. So by finding the middle element.
Yeah, if it's odd number, then it'll be one element that is not gonna move. But if it's an even number of the elements, then we'll just go to the middle.
Okay. So what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So odd. So what do we take? How would we find the split point with 11 elements? Divide by what? By 2 and take the lowest.
If we just divided length by 2, it will be integer number without decimal points. Yeah. So it will be 5.
5. Okay. Okay. So stop. Find. So find middle by dividing by 2, right? And taking whole number. So then we got 5. So basically 1, 2, 3, 4, 5. So here we split them, right? Like this. So fifth element is our middle.
Yes.
Cool. All right. So now we have basically we have the same array, right? We know that we have kind of this middle. So we know that element 0, 1, 2, 3, 4. The fourth, or did you want to do the fifth? So which the 55? Where would that kind of a middle element? So we divided 11 by 2, we got 5, right? So fifth element of the array, since it's a zero-based index, right? 1, 2, 3, 4, 5. So I guess middle will be here. So I guess we'll have some kind of we'll remember, right, that the middle is on the element number 5. That's 5. Okay, then what? So then start the swapping?
No, and we can create temporary. It's without the computer.
Nope,
Yeah.
yep.
Uh-huh.
In place, right?
Yeah, we can swap
Okay, so then,
first and last element.
all right, so let's kind of walk through this before we write any code. So we swap this guy with that guy with 5, 5 swap with 7, 6 with swipe with 6, and 8 with swipe with 1, 34 with swap with 1, and then we stop at the middle.
Yep.
Okay, so let's see what happens. So again, before we do any coding, we'll do the kind of really quick just walk through this, right? So we have 5, 2, right? So swap 5 and 2. Then we have 7, and then 5 goes here. Then we have 6 and 6, right? So we got 6, and then we got 6. And then we got 8 and 1, right? So 1 and 8. Not 80. And then we have 34 and another one. So 1 goes here, and then 34 go here. All right, and then we say stop. And obviously when we stop, we kind of leave 55 there. All right, so this is our middle. We said we're gonna stop until we get to element number 5. And that's what we're gonna get. So basically, is this the, so if we were to reverse it, we go 5, 7, 6, 1, 1. Oh, I deleted 1, that was here, right? Or no?
No, we don't need it there.
Was that?
No, I just said that we don't need it there.
So 5, 7, 6, 1, 1, right? 55, 34, 8, 6, 5, 2. Cool. Is this right?
Probably.
Looks like.
Yeah. Cool. All right. So now, once we have this brute force done, right, we basically kind of say, okay, this is how we do it in paper. You see, you don't have to write any code. Now you can, it's easy, right? When you put Java or programming language in there, you start thinking about loops, you start thinking about, how to solve it. And then I think, at least for me, you start taking your mind off of the actual problem. And when you start thinking about programming language and the problem, you have like two things getting into you, right? And when you have a little pressure, that becomes a little hard. So I recommend always to do this, right? Do it on paper. You kind of wrote the brute force. So this is our brute force. So no computer.
Sometimes we have no time for it.
No. That's,
I have just 7 minutes yesterday for my
So this took
assignment.
us what? Less than, it took us a couple of minutes because we were obviously, discussing this, right? And, participating as a class, and I was writing, all that stuff. But here you would do, probably a minute, right? Just to do, or even less. But what this saves you is the approach where you write the code and you figure out that it's not really a, logical thing, or the worst thing, you write the code, you run out of time, and it's wrong, so
So did you recommend to think and explain on interview what you are thinking about, or it's just for ourselves?
I think it's for yourselves, and you can certainly write it out like that. And I think that's going to show, at least when I interview people, it shows what they're thinking, right? That they're looking at the problem objectively. So, if you're whiteboarding, it's a whiteboard exercise or something like that, I would do something like this. This is kind of, you just say, okay, here's how I would do that. And from here, you can actually start writing the actual code, right? So, and when you do this, so you would be doing some kind of an array, right? So sometimes you write pseudocode, but for length of array, right? It's kind of a pseudocode. And, again, if you don't really have time for this, if it's, I don't know, some weird interview where they tell you write it in like 5 seconds, which, you're probably not getting a fair shot. Any interviewer should give you enough time to give it a thought, right? It's, we don't usually write code in real world where, somebody's sitting there with a timer. Nobody wants a super fast code. That's, even the companies that try to put the product out on the market, they care about quality. So, any good organization will let you estimate, and obviously, there is always going to be effort to be more efficient, but that should never go against quality and thinking and analyzing, right? So push for that. The good software takes time to develop. This is not, right as quick as possible. There is no competition and quick coding. In everybody wants quality software, because if you write fast, you're probably gonna write bugs, or you're gonna write shortcuts. So don't go for speed.
I'm sorry.
Oh, go ahead.
Sorry. Yeah, but I mean, wouldn't be kind of weird that you taking so long for some simple things? They would they would look at you like, come on, man, like you spending like 15 minutes for something that the regular QA engineer would solve like in 2 minutes.
Yeah.
And you
Well,
asking for 5-10 minutes, they like, oh yeah, right, you have 6 years of experience for sure.
This should not add a lot, right? Like we talked about here, this is basically, how your mind think, right? So wouldn't you, like you don't think in code, right? So you still, we're, humans. So, this shouldn't take, or writing kind of this 3 thoughts shouldn't take more than a minute, like, to me. So I think you'll get better at it, right? But it's going to give you clarity. So basically how this should work is you come to a problem like this, they say, okay, you need to reverse an array, and you kind of look at the array, you put out first, a quick sample for yourself, and you kind of go and say, okay, for this, here's what I'm going to do in my code. I'm going to swap the variables. Okay, somewhere I need to stop. Okay, what do I need to stop? Well, probably somewhere at the, the middle of it, right? Okay, so how do I find the middle? I divide the length by, the number of, the half, and, we'll probably take the whole number. So, and then, okay, so let me really think. I do this, and you just kind of reverse it. So that's like 20-30 seconds. So we're not talking about, adding a lot of time, and you're thinking, right? Like, how would you write code if you have no idea how you're doing the program? So wouldn't you have to think before that anyway? I would hope so, right? So like this should be kind of your, I recommend this to be your regular process. You have to think before you write code. So, and again, with some practice, this becomes a part of that, right? So, and then you kind of do, your coding, right? The first quick iteration for length of array, swap, first and last. Right? So is this good? Or will we go and say, okay, for length of array, well, no, because we have our index, right? For length of array until, middle, right? So you kind of do this int middle equals length divided by 2, and then you obviously do the till middle. So for I 0, I equal less than middle, right? Swap. So first and last. What do we put for first and last? How do we put first and last? How do we achieve that whole thing, swapping? How do we get to the first and last element? Do we have 2 counters? Or what do you guys think?
Caret.
I'm sorry?
Just char add method use.
Caret.
It's for first one.
Okay.
And for last one, we should make length -1. Index, yeah, char at length -1.
Well, that's all. We gotta keep decrementing this, right? Because this is going to stay static. So if length is, 11, then this is always going to be 10, right? So we probably want to have some kind of, last counter, right?
-I.
Oh, nice. Very cool. Like that. All right. Now we're cooking. All right. So that's, and then all we need to do is probably do some kind of a, if you really, you could probably do the swap as a, in method within the for loop, but if you have a little time, remember we talked about refactoring and all of that stuff, you can implement it, function reusable, and that's going to give you pointers, right? Because when you have something reusable, function, swap, what do you do there? You probably, since this is all inside of the same array, how would you implement swap? What would, so we need to take this element of the array and replace it and swap them with the other one. What are your thoughts on doing this? In place, right? We have to preserve the array. So what do you need to pass to the swap function? So you passing characters here, right? So you're passing 2 and 5, but you need to swap within the array, right? So you also need to pass the actual array probably, right? So when you're given your array as an argument, so you could pass the array, right? So then in the swap, you get array first, last, and then oh, can't spell that. All right, so how would you swap in the array first and last one for another? So thoughts? So it's index, right? You pass in index, last index. You need to, the array has to stay intact, right? So you need to take, again, remember this variable and that one. So you need to remember them somehow, right? You can't just take this and assign it here because you're going to forget this one. So
Yeah, we should create temporary variable
yeah,
for array for first index, for example. Yeah.
yeah. So array.
And then reassign first index to the last index.
Nice, right? So then array first index equals array. So now we're doing this, right? We're taking this, we remember 2, right? And we're putting it here. See? And then we gotta take the one that we remembered and put it in here at the last. So then array boom. Okay.
Yep.
Makes sense. This is very common exercise. So remember this, these are pieces that you're gonna take to your interviews and to your work. When you're swapping an array, that's why practice is the most important thing here. And thinking, right? So that's the core thing here. Get this stuff so it's part of your thinking about the problem. And you'll get fast at it. So the more you practice, if you practice for the interview, you're gonna have success. if you go to the interview without any practicing and you think you're gonna go by just theory, I guarantee you're gonna fail. You know, because when they have somebody who's looking at you and asking you questions, and they know that you're not really in it, you're just trying to write code, it's going to be obvious. So practice this stuff, practice thinking about this in a way where, you know, don't just rush to writing code. You can, you know, if you know you have to start writing code, if that's kind of what, you know, makes you more comfortable. If you want to start getting somewhere, if thinking makes you nervous that you're not, the time is ticking and you are, you know, not getting anywhere, fine, write pseudocode like this, right? But don't get into the, you know, exact things, because you're gonna again start thinking about the details of the implementation, and you're going to lose you know, the actual logic, and you're not going to solve the problem. You might write some code, but you're not going to solve the problem. So thinking is never a waste of time. So that's kind of the brute force approach, with some brute force pseudocode, you know, and then get the pseudocodes and, you know, just write the pseudocode real quick, and then you get basically, you know, as you see, comes from this, right? You know, we said we gotta go through the array, we're gonna swap, so that's why I put swap in there. Don't worry about how you do swapping in the, you know, the first thing. You put the logic, okay, it works, it does the same thing as we just did here. We go to the middle, we swap, and then you do the remainder here. So if you run out of time, you know, then you know, at least the interviewer will know, look, you got the code, all you need to do is just implement the swap. You can talk through that. But you know, the logic is there, it's, you know, it'll work. So, and then you have some nice you know, code that's really you know, kind of reusable function here for swapping as well. Any questions on this? Does this make sense, or is that helpful? No. All right, so for today, what we want to start on is another exercise I wanted to go through with the class, and then have you implement it. So let me just pull that up. So a lot more practice, because that's the only way. Oh, by the way, as I'm pulling that up, you guys remember for the interviews you had, this mock interviews, did you guys do the stacks and queues at all? Did that come up?
Can you repeat your question?
For the mock interviews you did you do anything with stacks and queues?
Actually, we didn't cover these things.
Oh, you didn't? Okay.
Yeah,
Okay.
I think I thought that we will in your classes.
No, I mean, did that come up with for the interviews? Didn't?
Mm-mm.
For the mock interviews? Okay. Fair enough. Yeah, we'll be doing exercises on that. But you know, the first one is going to be a little different. So do you so just kind of refresher from last time, do you remember what the stacks are and queues are? Can anybody tell me what's a stack? What kind of data structure? What does it do? What type of operations, and what, you know, remember last in first out, or first in first out? Which one is stack? Last in first out, or first in first out?
Last in, first out is the stack.
Cool. Yep. Yep. And the queue is obviously first in, first out, right? The first upper element you put in, the first is gonna come out. So like a line, right? All right, so let's see where this thing is. Okay, so we're gonna be doing this, and I want you to walk with me through the logic first, and then you're gonna just go out and write the code. So let me share my screen. All right. So problem, interview problem. Given an array of integers, return indexes of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So given numbers, array of numbers, find the two, and then a target, right? So you get two inputs in your function, array of numbers, and then the target. Find the indexes, so not the numbers, but indices. That's another, how you spell indexes, believe it or not, indices. So if you have this array and this target, obviously the first numbers that are summing up to this target would be at luckily at the first two places, so 0 and 1. So you'd return an array that would have those two numbers. So you take an array, you return a different array, and that array should have two numbers. So so basically the first available, right? And you cannot use the same element twice, right? So basically, if you were to be given a number 4 as a target, you can just say 2 and 2, right? You can't duplicate a number. So you have to find the other number that would, another 2. So it has to be two number 2s if you had a target 4. Okay, does the problem make sense?
Yes.
Any questions for the interviewer? Okay. I would just solve it. So let's start solving that. So let me give you an example, right? So 5, 6, 1, 4, 12, 30, 2, give a large array. I'll even do negative numbers so that you can have some fun. All right, and the target would be, let's say 7. Or yeah, let me do 11, just to make it a little fun. Okay, so how would you do that? Somebody walk me through it. How would you code this? What would be the thought process? What would your program do? And how would you do this, obviously without the program? What would you have to do? So you'd go through the array, right?
Yeah, we can go through array and start summing.
Okay. Start summing what?
Elements.
Okay, so let's so you probably will, which ones, like first to the second?
Yeah, one by one.
Okay,
Then second with the third with fourth.
okay, start summing elements. So each, so 5 plus 6, and if 5 plus 6 is not 11,
Then 6 and 1.
then 6 and 1. If 6 and 1 is not 11, then you do 1 and 5, right?
Mhm.
So
5 plus 6, it is 11, no?
right, yeah, I will change it. I didn't realize. I wanted to give an example that makes it a little bit more fun, so it doesn't. So let me do something that's a different target. I didn't realize that I had a 5 and a 6 here. Let's do something that doesn't come up right away. Let's do, how about we do 35. All right, so 2 numbers. So this will get you a little bit farther. All right, so, but the logic here is you sum first 2. So you sum elements and you kind of keep going with the counter, right? So sum first and second, then second and third, then third and fourth, right? So start summing element by increasing count of first and second element, right? That's what I'm hearing, right? So each sum will be increasing as you go, and check if sum equals target. Is this how you guys want to do it?
Yes.
Okay. Okay. Easy peasy then. So let's go through this. So 5 plus 6, not 35. 6 plus 1, not 35. 1 plus 5, not 35. 5 plus 12, not 35. 12 plus 30, not 35. 30 plus 4, 34, not 35. 4 plus 6, 4 plus 2, not 35. 2 plus 6, not 35. 6 plus 4, not 35. 7 plus minus 3, not 35. Minus 3 plus 5, still not 35. Now what?
We need to use nested loops here.
Oof. Okay. So this didn't work. What are we gonna do in the nested loop?
We're gonna check each index from the outer loop with the whole array.
Say that again. I didn't catch it. We're gonna check each index in the. So to explain that in without token indexes and stuff like that. So what are we gonna do here? We're adding each number and we're continuing. What are we gonna do in the inner loop? Or
We'll just grab the one index from the outer loop, and then in the inner loop, we're gonna sum it with each of the following indexes. And then once we find our sum, we will just break out from the loop.
nice. Okay. So we're gonna do, so instead of sum, are we doing this or we're scratching this? We don't like this anymore. So, right, we're removing this or we're keeping this?
Yeah, we're removing it. I thought that these two numbers should be should go one by one and get the sum of target. But if
Oh.
yeah, mhm.
No, it doesn't matter, right? So of the two numbers, so they don't have to be right together or anything like
Yeah,
that.
yeah, that's why it's important to clarify
Yes.
before
That's why I
the
asked if any
solution.
questions for the interviewer, right? So
Uh-huh.
make sure, please, that you are super clear on the problem. Otherwise, you're gonna solve something and gonna be like, I did it in half of the time. I am your best Java developer. Hire me. And I say, you know what? You did it, but you didn't solve what I asked you. So don't rush. Again, that's why I'm trying to get you guys to think about this so that you don't just start writing your shiny cool loops. All right, so then we're gonna go through an array through each element of array, right? So this is kind of the logic. And then you're saying I'm gonna do this little, I'm not gonna say loops yet for, and like you said, sum the element with each subsequent element. And then check if sum equals target. Break. Is this how we're thinking, the logic? So
Looks like it, yes.
is that okay? So
I
basically,
have a question here.
yeah.
Could be sum of the two numbers, or it just could be just in the array it can contain 35.
Sorry, I didn't catch that. Can you
It
repeat it?
should be, by the requirement, it should be sum of two numbers,
Uh-huh.
or it could be just contain in that array list 35.
No, it has to be a sum of two numbers.
Okay, got it.
Yeah. So you cannot, right? So you may not use the same element twice, right? Or just finding, it's not a finding an element. You have to have the two numbers that they add up to the specific target. Good question. Yeah, it's not a find in array, it's a find the two numbers. So, all right, so we take in, let's go through this real quick. So this one sounds good. And again, don't get discouraged by me talking and it's taking time, because you're going to be doing this in your head really quick, right? So you're doing 5, you're taking 5, then you're adding 5 plus 6, not 35, and 5 plus 1 plus 5, and you kind of going through this, right? You go through the whole thing and you are finding 35 when you get 5 elements after this. So this looks good, right? So you kind of say, okay, it looks like it's working. So this one worked. You basically, you got lucky on the first iteration, so you get the 30, the 5. So I would quickly, just to verify, right, give yourself a different target. So maybe do, I don't know, like 19. So then you make sure that you're not just, so then you go 5 through, there isn't anything where you're going to get 19, 6, 17, nothing that does 19. Nothing here. And then you'd say, okay, because you know what's going to give you 19, right? You kind of do 12 and 7. So you kind of say, okay, I get to the 4th in the outer loop, 4th element 12, and you're gonna you skim through this and you say 18, and then you get your 19 here when you get to the 7. So looks like it's working, right? So you got 2 cases where the easy one. So then you go, that works, right? So then you got your pseudocode, you got your logic. Now you gotta just, the easy part is coding. So you gotta code it. So code it. I'll give you, what will this take? 5 minutes? 10 minutes? What do you guys need? What if in the
Let's
interview
do it 5.
5? Okay.
Mhm.
All right, I'll leave my screen like this so you can see the actual problem and then the pseudocode we wrote. So go ahead. Whoever does it first, let's see, since there was a question on fast coding, let's see if there are super fast coders there with that we have the logic. Just let me know who's done first. All right, how are we doing? Not done yet? Okay, a few more minutes. All right, how we doing? Anybody finished?
Yes.
Cool. Does it work?
Yes, it works.
Sure. Let's take a look. I'll share.
You want me to share? Okay. And this one. That's the logic.
Mm-hmm.
And here's the output.
Yeah.
My target sum was 59.
Okay. So then your
Yeah, here's my array and here's my sum.
yeah. Nice. Okay. Yeah. No, that looks good. I would you know, from kind of the best coding practices, I would suggest naming array to like return array, usually, you know, like a return array or so, or return value, so just to kind of understand what it is. So a little bit more meaningful, like return array or something.
I just had something from yesterday from the mock interview, so I just used that.
Okay. Other than that, it's good. Find target sum, like the name. Good. Okay. All right. That works. Anybody had issues with the exercise, getting through it? No? Cool. All right, well, good. So hopefully this was useful. Went through a few exercises and basically worked through things together, and you have that tool in your toolbox, right? Brute force, pseudocode, change to real code. Just a little bit of a structure will help you stop sometimes and think without staring at, you know, the loops and all of that stuff. So, all right. So the homework is going to be, so let's talk through that. The exercise for home will be around the stacks and queues. So let's talk through that real quick. And then also I want to mention what we're going to study next time, next Thursday. So we've talked about stacks and queues. We're going to do some homework, like I said, which was gonna help you do more coding. And next Thursday, we're gonna talk about hash tables. So we will talk about sets, hash maps. So anything that has to do with hashes, which is kind of the concept here, but you know, you can call them hashes, dictionaries, but it's a key value pair type of structure. So very, very common, important. Have you guys worked with hash tables, hash sets, any of those things? Any key value pair data structures in this class?
We worked with the hash sets, but not with the hash tables.
Oh. Hash sets, I believe it's very, in Java, very, very similar to hash tables. It's a collection of key value pairs, I believe, right? I'm just looking at the Java documentation, Java doc for that. So yeah, so we'll talk through all of that, and get a little understanding of all of that stuff. So, although, well, yeah, hash set is it's more of a, it's a collection, but not key value pairs, right? It's more of a like a list, if I'm not mistaken. Yeah. So hash set doesn't really feed the hash table type of stuff. I think it's more of a list in Java. So, but yeah, we'll go over the actual hash tables and kind of key value pair structures. So that's going to be the topic for next time. So so let's go through the homework and just let me know if you have any questions. I wanted to quickly. So you have a choice basically. So either stack or queue, right? So we've talked about stacks and queues. We've talked about array list, linked list. So the homework will be, and I'll post it today, but basically choose which data structure you want to implement. So don't use Java stacks or queues, but basically use a underlying data structure. Remember, it can be implemented with array list or linked list, or an array, whichever data structure you choose. So pick a data structure, pick a stack or queue, and then implement the following operations. So if you do the stack, push pop, and is full and empty, right? So basically, check in whether the there's elements in the queue. So for simplicity's sake, let's do let's do just is empty. So because is full basically means that you have to have some kind of static array, and I don't want you to do that. That's not necessary. So for stack, push, pop, and is empty. So this three, and for queue, the queue, and is empty. So another one I forgot, peep, very important one. Return item without removing structure, right? So that's the peep operation. Return an item, so you just return it, but you don't really remove it from the data structure. So use any list data. This operation should be O1, right? Always O1. So no matter how big the queue is, how many items or you have in a stack, adding an element, removing elements. So basically you have to be able to get, well, I don't want to write that down, but basically for whatever data structure you have, you need to be able to get to the first and last element instantaneously. So without looping through the entire data structure. All right. Any questions on this? Makes sense. Put that in here. The Codewell channel. So that sounds straightforward. So basically, you're gonna have your class, right? Your queue or stack class, and then as a private variable in there, you're gonna have your data structure. So your the data hold will be whatever list, array list, linked list, or array, and then you're gonna have those four methods: queue, dequeue, is empty, and peep, and those should have O1 runtime, the push and pop. So you need to be able to have a driver program as well, right? To use your data structure like a main method. So you add an element, remove an element, check is empty. So just the usual stuff. Okay. So that's for Thursday, for next Thursday. And then for Tuesday, please finish the animal game that we talked on Tuesday, right? I think somebody was already pretty close there. So please finish that. That's super important. By the way, did you guys get any questions on your mock interview about abstract classes, interfaces, that type of stuff?
Yeah, I had them. I had
Oh,
a
you
lot.
did?
Yeah,
So were you able to answer them?
I thought I did. I don't know. Didn't get that much feedback on that topic.
Oh, okay. So how'd you know if you passed the interview? How'd you guys know if you passed or didn't pass?
We didn't know.
Oh, okay. So I'm sure Oscar will tell you. All right, sounds good. So that's the homework. So now you have two hopefully pretty interesting exercises. So continue practicing and
Igor,
yeah.
sorry, I
Yes.
didn't get the homework. Can you explain once again, please?
Sure.
This last one.
Yeah. So using so you're gonna implement use any list type data structure, array list, linked list, array, to implement one of the following classes. So either you choose one, so choose one, right? So stack or queue. So you can look at the the definition of stack and queue, but remember stack is a last in, the last in first out, right? So it's kind of stack of pancake. So basically you can push things on it, you can pop, the last thing you push is the first thing that will be retrieved. So basically that's your stack, right? So if you're pushing elements in the stack, like let's say 3, 4, 5, 2, right? If you continue pushing and then 3, so you push that, as you can see, the last one to pop, when you pop, you're gonna get 3, and then you get 2, and then get 5, 4, 3, right? So basically, as you push things in, you're building that stuff, and the first one you push is the first one that's gonna come out. So that's what you're going to implement here, and it should be O1 operation. So doesn't matter how many items of the array, you should be able to get to this element instantaneously, right? And you should be able to push things, add to the whatever list data structure you choose instantaneously. And then the peep operation is going to be, if you have this stack, when you do the pop, you basically remove this item, right? So the pop will remove this, then remove that. And the peep operation will basically, just return this element, but the actual underlying data structure will be unchanged. Okay? Does that make sense?
So we need just to practice with the different types of data structures?
No, just choose one. You choose one that you feel is going to be the best fit for it.
Ah, okay. Okay.
Got it? Yeah. And the queue is completely different. It's completely reversed. So in the queue, as you may remember, if this is your queue, if you add a 3, 4, 5 to and then you do DQ, you get completely reversed, right? So you get 3, 4, 5, 2, 3, right? So basically your DQ removes 3, removes 4, removes 5, removes 2, removes 3. So it's kind of like a line. So yeah, choose the data structure, but again, you need to choose the data structure where you can add an element and without traversing anything, right? So that's going to be O1 operation. So if you're not sure, do some quick Google the data structure, add should O1, and then remove whichever you decide to remove here. You're going to have a top element you're going to be removing in this pub. So you need to make sure your data structure allows you to get to the last element by index or something like that. So it's O1 operation.
Okay, thank you.
More clear? So this will have you practicing, even though you may not be using stacks and queues, a lot, it doesn't matter. This is a practice for a link for lists. So, and obviously your coding skills. All right, well, that's all I have for today. As always, please feel free to drop me a note, but please get these exercises. So this is the only way to get you guys coding successful and prepared for interview. Coding is like language, right? You're learning Java, you gotta speak it. If you don't speak it, you're not going to be successful. So it's time. All right, and have a good weekend.
Yeah, you
Thank
too.
you, Igor.
Thank you.
Thank you.
Thank you.